Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson Bias and Fairness in AI Systems. Bias and fairness in AI systems are critical considerations for modern leaders aiming to harness the power of generative AI responsibly. AI systems, particularly those based on machine learning, rely on vast datasets to train their models. These datasets inherently reflect the biases present in the data collection and selection processes. As AI systems become more integrated into decision-making processes across various sectors, the need to address these biases and ensure fairness becomes paramount. Bias in AI can manifest in numerous ways. It can be present in the data used to train the models, the algorithms themselves, or the way these models are applied. For instance, historical data may reflect social inequalities, leading AI systems trained on such data to perpetuate these disparities. This phenomenon was evident in a study by Angwin et al., which found that a widely used risk assessment tool in the criminal justice system was biased against African Americans, predicting higher rates of recidivism for Black defendants compared to white defendants with similar profiles. Another significant example of bias in AI systems is the gender bias observed in natural language processing models. Bolukbasi et al. Demonstrated that word embeddings, which are foundational to many NLP applications, captured societal stereotypes. For instance, the model associated the word man with computer programmer and woman with homemaker. Such biases in AI systems can reinforce harmful stereotypes and lead to discriminatory outcomes. Fairness in AI involves creating systems that are impartial and equitable across different demographics. One approach to achieving fairness is through the careful selection and pre-processing of training data to ensure it is representative and free from bias. Another approach is algorithmic fairness, where algorithms are designed to make unbiased decisions. However, achieving fairness is a complex task because it requires balancing competing notions of what is fair. For example, ensuring equal opportunity for all groups might conflict with achieving equal outcomes across those groups. Statistical methods can be employed to detect and mitigate bias in AI systems. One common method is the use of fairness metrics such as demographic parity, equalized odds, and disparate impact. Demographic parity ensures that the decisions made by an AI system are independent of sensitive attributes like race or gender. Equalized odds require that the true positive and false positive rates are equal across different groups. Disparate impact measures whether decisions disproportionately affect a particular group. Tools like IBM's AI Fairness 360 and Google's What If tool provide frameworks for assessing these metrics, making it easier for developers to identify and address biases in their models. The integration of bias detection and mitigation strategies into the AI development lifecycle is crucial. This involves ongoing monitoring and auditing of AI systems to ensure they remain fair over time. A notable example is the work done by Microsoft in developing their AI principles, which emphasize transparency, accountability, and fairness. Microsoft has implemented these principles by incorporating fairness checks throughout their AI development process and regularly auditing their systems. Real-world applications of AI highlight the importance of fairness in AI systems. In the healthcare sector, AI is used to predict patient outcomes and recommend treatments. However, if the training data is biased, the AI system may provide inaccurate predictions for certain demographic groups, leading to unequal healthcare outcomes. Obermeyer et al. Found that an algorithm used to allocate healthcare resources in the United States was less likely to refer Black patients to programs providing extra care, despite these patients being equally sick as their white counterparts. This disparity arose because the algorithm used healthcare costs as a proxy for health needs, and Black patients had historically lower healthcare expenditures due to systemic inequalities. Similarly, in the hiring process, AI systems can perpetuate existing biases if the training data reflects historical hiring practices. Amazon's AI recruiting tool, for example, was found to be biased against women because it was trained on resumes submitted to the company over a 10-year period, which were predominantly from men. As a result, the tool downgraded resumes that included the word women's, such as in women's chess club captain. This example underscores the need for diverse and representative training data and highlights the potential risks of deploying AI systems without rigorous fairness assessments. Addressing bias and ensuring fairness in AI systems also require a multidisciplinary approach involving experts from fields such as ethics, sociology, and law, in addition to computer science. This collaborative effort can help identify potential sources of bias and develop strategies to mitigate them. Furthermore, involving stakeholders from diverse backgrounds in the design and evaluation of AI systems can provide valuable insights into the system's impact on different communities and help ensure that the AI serves the broader societal good. Ethical AI governance frameworks play a crucial role in promoting fairness and mitigating bias in AI systems. These frameworks establish guidelines and principles for the responsible development and deployment of AI. For instance, the European Commission's high-level expert group on artificial intelligence has developed guidelines for trustworthy AI, emphasizing principles such as human agency, fairness, transparency, and accountability. Adherence to such frameworks can help organizations navigate the ethical complexities of AI and ensure that their systems align with societal values. Transparency is a key component of ethical AI governance. Organizations should be transparent about the data sources, algorithms, and decision-making processes underlying their AI systems. This transparency enables external scrutiny and fosters trust among users and stakeholders. Explainable AI techniques, which aim to make AI decisions understandable to humans, can enhance transparency and accountability. For example, the local interpretable model agnostic explanations technique provides insights into the factors influencing an AI model's decisions, helping users understand and trust the model's outputs. Accountability mechanisms are also essential for ensuring fairness in AI systems. Organizations should establish clear lines of responsibility for the development, deployment, and monitoring of AI systems. This includes defining roles and responsibilities for AI governance, implementing regular audits and impact assessments, and creating channels for reporting and addressing potential biases and unfair outcomes. Regulatory bodies can also play a vital role in enforcing accountability and ensuring that organizations adhere to ethical standards in their AI practices. In conclusion, bias and fairness in AI systems are critical issues that require careful consideration and proactive measures. Addressing bias involves recognizing the various sources of bias, employing statistical methods to detect and mitigate bias, and integrating fairness checks throughout the AI development lifecycle. Ensuring fairness requires balancing competing notions of what is fair, involving diverse stakeholders, and adhering to ethical AI governance frameworks. Transparency and accountability are key components of ethical AI practices, fostering trust and ensuring that AI systems align with societal values. By addressing bias and promoting fairness, modern leaders can harness the power of generative AI responsibly and contribute to a more equitable and just society. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.